Okay, we need to talk about side effects. So far what we did was sort of pure functional programming. So we really had functions in the mathematical sense that the output is fully determined by the input. And if that's the case, well, okay, it sounds like, yeah, obvious. If that's the case, things are quite easy. So this is, well, let's see what I mean by that exactly. So if I have the string function, okay, if I don't give any argument, it just gives the empty string, okay? And this is going to be the case all the time. So if a stir is called with no argument, I get the empty string. And well, if I call with number 42, then it will produce the string 42, okay? And it's no matter how many times I evaluate this is gonna be the string 42. So I look at the function stir and look at the input, and the output is clear. You know, it's the mathematical definition of a function is that for any valid input you will get exactly 1. So no more than 1, no less than 1, exactly 1 output. Okay? And as I said, well, this is what's called a pure function, if this is true. Look at this function, okay, rand. And that's, okay, that gives a random number between 0 and 1. Okay, so if I evaluate it again, oh, it gave another number, another random number. I'm calling the same function and I'm getting different answers. Okay, so it's like rand is not a pure function. It's not a mathematical function. Okay, so that's what it means, that, you know, when I call this function and again, something is changing in the background. Well, yeah, sure, there is a pseudo random number generator which has a state, a particular state, and that's keep changing. So it's like, well, sure, if rand was just giving the same number all the time, it wouldn't be random, right? So what I'm saying here, that if you want to deal with the real world, and that's like, well, at some point you have to have some functions that are actually doing something to the word. So what do I mean by that? Well, there is this function. So in most languages, this is what you do first. Okay, well, that's interesting because it's where is it printing? Okay, well, that's quite interesting. So you see that the return value of print is nil. And this, what this does, this writes on the screen. And okay, this is quite strange, because since we have this interactive environment, the REPL here, the Maria Cloud, we simply don't need this. We never write on the screen, because, well, the output of the function is automatically there anyway. Okay, so let's go to another REPL. It's a closure REPL, not closure script. It's just to show my point. And here, okay, so if I want to print line, well, it says that can have a couple of arguments. Yeah. So this is how you start most programming languages, to write on the screen. And if I evaluate this, well, you see that it writes on the screen, hello word appears there, and it also says nil, which is the value of the function. So it returns nil, but it does something else. So this is a very tricky function if you are coming from the mathematical world of functions, where if you are a function, you just calculate a value and you don't do anything else. This does. And of course, when you work with computers, eventually you have to do something. You have to do some input-output. You have to write to the disk. You have to send some information over the network. That all changes the world. That's where you sort of leave this very nice mathematical world of pure functions. So this is actually quite a trick as well. It's like programmers of the older generation. It's like we sometimes tend to do things in a very simple way. And let's say if I have a function that takes x and I just calculate something nonsense okay. So I have f of 2. Okay, I have 4. But imagine that I'm not happy with the with this result somehow, and I want to do some debugging. So one way to do that is like I can put a print line into the function, and it's like say my input was x. Okay. And now if I call my function again, f of 2, okay, it says 4, which is the output of the function, and it also says my input was 2, so that does something else. So it's like, yeah, when we do debugging, often we just do it in this very simple-minded way. We think about it, and we just put some print line statement wherever we want to get some information. Okay, but it is a very important thing here is that when you define a function, okay, it's like you can have different expressions inside, and only the last one is returned. And the reason for that is that there is this do statement. So if I do a couple of things, I increment 1 and I increment 2, and I evaluate that, I get 3, and I only get 3. 2 is thrown away. So this, if this do block, you get you can evaluate some expressions, but only the value of this do statement is the last one evaluated. So that's why I can, and that you get that in the function as well. This is the problem. If you remember, there's the function not called. When you in the body of the function you forget to call a function, you forget to put it into parentheses, and you have just lots of pieces, the function, first argument, second argument, and it just returns the last argument, and that's the reason. Okay, so yeah, why am I showing this? Because if you do some graphics programming, as a graphics is another thing, when you really want to change the word, you want to change the content of the screen. Okay, so it's like then this might come handy. Okay, so this is doSeek is just like 4, except that you can use it with a function that has a side effect. Okay, wow, what did I do wrong? T is missing here. Ah, yeah, that makes sense. Okay, again, as the return value is nil, we are not returning anything, but we could do a lot in printing to the screen. Okay, again, the reason why I showed this, because if next you want to play with some computer graphics or animations, then you will do a lot of do-seek, which is just doing that. So let's see. If I plan to use this just as with 4, okay, and we have that. Okay, you get nothing, you get nil, because the do-seek works like 4, but it's not producing the sequence. It expects that while you do some side effect there. Okay, so, well, again, the reason why I went to this other system, the closure, because, well, here in the REPL, it's all nice. We never had to think about writing on the screen, because whenever you have an expression, it's evaluated, then you get the value printed anyway. And even if it's a composite structure, Maria Cloud is good enough that, well, you can actually investigate that composite structure. Okay, but if you want to do real programming, eventually you have to do something with a side effect. And this also explains that why am I at if you just write a little function, you know, that's meant to do something, and sometimes I saw people writing you know, it's defining m to be 2, and now it's like I want x plus m together. Okay, so this function, let's say f of 1, I think that's 3. Okay, so it's like this is the x plus 2 function, but this is a very, very nasty function, because now, what is m? M is 2. It pollutes the environment. Okay, so it's not just producing a value, it changes the word. It defined a new value, and you know, this value might be something that is defined in your environment and someone else is relying on that, and now this function changed that. So this is the source of problem. So that's why you just never do this. Okay, it's like, as long as you can write pure functions, just write pure functions. Don't change the environment, don't change the word in that function. Okay. So yeah, it's I mean, there is a lot more to say about this, and this is actually, it's a big difference between the sort of more traditional imperative programming, where you basically explicitly work sort of all the time with the memory, and you change the content of the memory, while in a more functional or a purely functional language, you just basically evaluating functions, and you never have to deal with the notion of a state and changing state. However, of course, at some point you have to. So basically, it's a good style, and that's the recommended style. That if you have an application, you write something bigger, you want to figure out what is sort of the pure functional core of your problem, where you just have functions that don't have any side effects. Okay, and separate that, and you can easily test that, and then you deal with the rest. Okay, but for now, for the final topic, if you want to do some computer graphics with that, you just need to be aware of that. For example, do seek and functions with side effects.